4 billion miles from Earth in 1990, a spacecraft called Voyager 1 rotated its camera back toward the inner solar system and captured something that should unsettle every person alive. What appeared in that photograph was a single pale pixel, barely visible against the cosmic dark, and that image revealed a truth about our planet that most people still refuse to accept. You probably believe Earth is permanent, that this world will patiently wait while humanity sorts out its politics and economics and territorial disputes. Venus believed something similar once. Our nearest planetary neighbor shares almost identical dimensions with Earth, and both worlds condensed from the same primordial cloud roughly 4.5 billion years ago. Venus may have harbored oceans in its youth. 900 degrees Fahrenheit now bakes its surface, hot enough to melt lead, and the margin separating us from an identical fate turns out to be thinner than anyone wants to admit. None of this is speculation or environmental rhetoric. Planetary science delivers this verdict. And once you absorb what that science tells us about Earth's fragility, your perception of everything changes, from how you view your morning coffee, to your commute, to your arguments with strangers on the internet. Here is what the data actually shows. Most of human history operated under the assumption that Venus was Earth's twin, the morning star and evening star, wrapped in mysterious clouds, orbiting just slightly closer to the Sunday. Scientists during the 1950s imagined tropical jungles hiding beneath that thick atmosphere, warm oceans lapping at alien shores, and perhaps even life forms thriving in perpetual twilight. December 1962 brought a reckoning when the Mariner 2 spacecraft completed the first successful mission to another planet and measured conditions that should have terrified everyone paying attention. Surface temperatures registered as infernal rather than tropical. Atmospheric pressure reached levels that would crush a submarine. Sulfuric acid rains from clouds that never part over a landscape no human could survive for a single second. Engineers have a term for what happened to Venus, and they call it a single point of failure, with no redundancy. One thermostat governed that planet's temperature, specifically its distance from the sun, and when conditions shifted, no backup system existed to compensate. The mechanism behind this transformation carries an elegant horror to it. Our sun burned slightly fainter when the planets were young, and as our star gradually brightened over cosmic time, Venus received marginally more heat due to its closer orbit. Water started evaporating from the surface into the atmosphere, but here's the thing about water vapor. It traps heat. Additional heat caused more evaporation, and additional evaporation trapped more heat still. That feedback loop, once initiated, could not be stopped. Oceans boiled away completely over geological time. Liquid water had previously absorbed carbon dioxide and locked it into rocks through the carbon cycle. But without that mechanism operating, CO2 accumulated in the atmosphere instead. 96% carbon dioxide now comprises the Venusian atmosphere, pressing down with nearly 100 times Earth's atmospheric pressure. Scientists named this process the runaway greenhouse effect, and it functions not as a metaphor, but as a phase transition. A world that may have been habitable crossed a threshold and transformed into something unsurvivable, with no path back to its former state. Earth orbits farther from the sun, which means we are not becoming Venus next Tuesday. But the lesson screams at us anyway. Planetary climates exist within what astronomers call the habitable zone, and that zone has edges. A world much like our own can cross one of those edges and never return. Venus sits next door, not as ancient history, but as a warning signal we can observe every evening in the western sky. Consider for a moment what separates you from the vacuum of space. Step outside on a clear day and look up at that blue gradient visible at the horizon during sunset, because that thin band represents the totality of Earth's atmosphere as seen from the surface. Driving a car straight up at highway speed would carry you beyond the breathable portion in roughly 1 hour, just 60 minutes between you and the void where no human can survive unprotected. The atmosphere dense enough to sustain human life extends only about 3 miles above sea level, a distance you could walk before lunch. Every breath drawn by every human being who has ever lived occurred within this gossamer envelope of gases clinging to a rock. Earth's atmosphere functions like a firewall, with the ozone layer blocking ultraviolet radiation the same way security software blocks malicious code. Compressing that ozone layer to sea level pressure would produce a thickness of only 3 millimeters, thin enough that 2 stacked coins could cover it. We cannot reinstall this protection if it crashes. Decades of releasing chlorofluorocarbons burned holes through it before anyone noticed the damage accumulating overhead. This thin membrane creates the only difference between Earth and the airless moon. Both worlds receive light from the same Sunday. Both worlds endure the same cosmic radiation, sleeting through the solar system. The moon bakes and freezes through endless cycles as a dead world, while Earth teems with life From hydrothermal vents to Himalayan peaks, atmospheres make that difference, and atmospheres can be changed. The early 1980s brought a discovery that still produces nightmares. Made during the height of the Cold War, when my colleagues and I were studying how Martian dust storms could dramatically alter the red planet's temperature. Mariner 9 had observed Mars engulfed in a global dust storm back in 1971, and we developed computer models simulating how fine particles interact with solar radiation and atmospheric heat. That's when we asked a different question about what would happen to Earth's atmosphere following a nuclear war. The calculations devastated everyone who saw them. A major nuclear exchange would ignite cities, and not merely through buildings destroyed by blast and radiation. Firestorms would consume entire urban areas the way they did in Hiroshima and Dresden. Hundreds of millions of tons of smoke and soot would climb into the upper atmosphere and spread across the hemisphere. Physics revealed what would happen next. Black particles absorbing sunlight in the stratosphere would heat the upper atmosphere while blocking the sun from reaching the surface below. Global temperatures could plunge by 20 or 30 degrees Fahrenheit within weeks. Sub-freezing temperatures would arrive in midsummer. Darkness would fall at noon. Agricultural growing seasons would vanish across the northern hemisphere entirely. We named this phenomenon nuclear winter. Game theorists describe competitions where even the winner loses everything as negative sum games, and humanity had created the first technology in history where successful deployment meant destroying the deployer. What should break your brain is that we accomplished this without ever calculating the atmospheric effects. 4 decades of nuclear weapons development passed before anyone modeled what using them would do to the planet's climate systems. Physicists who built those arsenals understood blast radii and radiation dosages perfectly well, but nobody thought to check whether nuclear war was survivable at the species level. We constructed the gun before realizing it pointed at our own head. This captures what I mean when I describe Earth's fragility, not weakness in the conventional sense, since we have demonstrated astonishing power to reshape our environment, but fragility in the sense of operating without margins for error. The systems sustaining us lack infinite resilience. Actions taken without fully understanding consequences can disrupt them permanently. Nuclear winter remains terrifying, but it represents a sudden catastrophe that we can choose to avoid. The doomsday clock maintained by the Bulletin of the Atomic Scientists reminds us how close we remain to that choice, but choosing remains within our power. A slower danger presents itself, more gradual, and in some ways more perilous because it lacks dramatic urgency. Earth possesses a greenhouse effect similar to Venus, with carbon dioxide and water vapor trapping heat in our atmosphere. This feature is not a flaw. Without greenhouse warming, Earth's average temperature would drop below freezing, the oceans would become ice, and life as we know it could not exist. A modest greenhouse effect proves essential to everything we care about. The problem emerges from how rapidly we are adding to it. Most of Earth's carbon has always remained locked away in limestone, coal beds, frozen organic matter from ancient forests, and shells of marine organisms that drifted to the seafloor over hundreds of millions of years. The carbon cycle operating across geological time kept atmospheric CO2 within a range suitable for complex life. We are now running that cycle in reverse, burning fossil fuels that required epochs to accumulate releases stored carbon into the air at a rate unprecedented in Earth's geological record. Carbon dioxide levels set at 280 parts per million before the Industrial Revolution, but readings now exceed 420 parts per million, higher than at any point in the last 3 million years. The year 2023 brought Earth's hottest temperatures in 125,000 years. What we call climate change today was visible in the mathematics of planetary atmospheres long before it became political. The surface of Venus stands as a warning that something disastrous can happen to a planet much like our own. Even a 1 or 2 degree rise in global average temperature, which sounds trivial when spoken quickly, cascades through interconnected systems in unpredictable ways. Ice sheets destabilize, ocean circulation patterns shift, agricultural zones migrate faster than farmers can adapt to new conditions. Thousands of scientists from 195 countries comprise the Intergovernmental Panel on Climate Change, and their collective conclusion states that human activities are unequivocally warming the planet. This represents consensus achieved through decades of measurement, modeling, and verification, not controversy. Perspective on time might help here, because perspective is precisely what humans lack when contemplating their situation. Imagine compressing the entire history of the cosmos, all 13.8 billion years of it, into a single calendar year. Call this the cosmic calendar. January 1st at midnight marks the Big Bang, when matter and energy burst into existence. The Milky Way galaxy assembles from primordial gas by mid-March. Our Sun and Earth appear around early September. First, microscopic life emerges around September 21st. October passes with life remaining single-celled and invisible to the naked eye. November passes the same way. Most of December continues this pattern. Complex animals appear only during the last week of December. Dinosaurs roam on December 25th and vanish on December 30th. All of recorded human history, every pharaoh and emperor, every war and revolution, every cathedral and constitution, every love letter and mathematical proof, every person whose name you have ever heard occupies the final seconds of December 31st. The pyramids rose about 11 seconds ago. The Roman Empire collapsed 6 seconds ago. Columbus reached America 2 seconds ago. The entire Industrial Revolution, both world wars, the invention of computers, the moon landing, and everything since happened within the last cosmic second. One cosmic second spans fewer than 500 years, and during that time, we have measurably altered Earth's atmospheric composition, split the atom, created synthetic chemicals persisting for centuries, and triggered what biologists recognize as the sixth mass extinction in planetary history. Future geologists, assuming any exist, will identify our presence in rock layers as easily as they identify the asteroid impact that ended the dinosaurs. They may name this era the Anthropocene, marking the epoch when a single species altered the geology of an entire planet. Humanity now represents a new and possibly decisive factor in Earth's evolution. Intelligence and technology have granted us power to affect climate, chemistry, and biodiversity at planetary scales. Whether we possess wisdom sufficient to use that power responsibly remains the open question. Nothing punctures human arrogance quite like viewing our planet from deep space. That Voyager 1 photograph shows Earth as a fraction of a pixel, a pale blue point suspended in scattered light from our distant Sunday. Neuroscientists have found that viewing Earth from this perspective activates neural pathways similar to those triggered when contemplating mortality. The image does more than inform. It confronts viewers with their smallness. Think about what that single pixel contains. Everyone you love lives there. Everyone you know lives there. Everyone whose name you have ever heard lived out their existence on that tiny point of light. The accumulated joy and suffering of our entire species resides there. Every confident religion and ideology emerged there. Every economic doctrine was written there. Every hunter and forager, every hero and coward, every king and peasant, every mother and father, every hopeful child, every teacher and tyrant, all confined to a mote of dust drifting through cosmic darkness. Our posturings and imagined self-importance, the conviction that we occupy some privileged position in the universe, all of it crumbles when confronted with this distant view. Earth is a lonely speck in the great enveloping void. Nothing in all that immensity suggests help will arrive from elsewhere to save us from ourselves. Astronauts who have observed Earth from orbit describe something called the overview effect, a cognitive shift producing profound awareness of planetary fragility and unity. National boundaries become invisible from that height. Conflicts seem incomprehensible. The thin blue line of atmosphere appears impossibly delicate against the blackness of space. Spaceflight remains beyond reach for most of us, but this photograph exists. Looking at it honestly should change anyone who does. Earth remains the only world known to harbor life. Nowhere else, at least in the foreseeable future, offers a destination where our species could relocate. Visiting other worlds remains possible. Settlement does not, at least not yet. Like it or not, this planet is where humanity makes its stand for now. What a world to defend. The nitrogen woven into your DNA, the calcium forming your bones, the iron circulating through your blood. All of these elements were forged in the cores of massive stars that exploded billions of years ago and seeded the cosmos with raw materials for planets and people. We exist not merely on the universe, but as part of it. Stars disassembled and temporarily organized into beings capable of contemplating the stars that made them. Cosmic evolution, producing matter capable of reflecting on its own origins, represents the deepest wonder. We are the universe, examining itself. We exist on a world balanced on a knife's edge, warm enough for liquid water, cool enough to avoid boiling away, blessed with an atmosphere thick enough to breathe and thin enough to reveal the stars. Evolution has never previously produced a species capable of coordinating action at global scale. Every organism that ever lived operated on local incentives, immediate rewards, and tribal boundaries. What we now require of ourselves, sacrificing present comfort for descendants we will never meet, cooperating with strangers across oceans and continents, valuing species survival over quarterly profit, has no precedent in 4 billion years of life on this planet. And yet this path is the only one that does not terminate in the fossil record. The Roman Empire did not collapse from a single invasion. Decline came because adaptation failed when conditions shifted in climate, economics, and political structure beyond what existing institutions could handle. A civilization that had solved every problem for 1,000 years could not solve the new ones emerging in the 4th and 5th centuries. We are Rome. The only question is whether we possess imagination sufficient to become something else. The significance of our lives in our fragile world is not inscribed in the stars. Our own wisdom and courage determine it. We serve as custodians of meaning itself, a cosmic parent watching over us, forgiving errors, rescuing us from folly would certainly be preferable. The universe extends no such comfort. Knowledge, regardless of difficulty, beats reassuring illusions every time. Astronomy has long been described as a humbling and character-building experience, and this description proves accurate. Understanding the vast scales of space and time, seeing Earth as a small world adrift in an ocean of night, shifts something internal. Border disputes start seeming absurd. Resources wasted on weapons capable of destroying civilization multiple times over become obviously and tragically insane. What we need is something that might be called a cosmic conscience, a perspective transcending the tribal loyalties and short-term thinking that evolution wired into human brains over millions of years. This does not mean abandoning local identity. It means expanding moral concern to encompass the planet and the future simultaneously. Our ancestors could not affect global climate. We can. Our ancestors did not possess power to extinguish most life on Earth. We do. Power of this magnitude brings responsibility unprecedented in the history of our species. Our pale blue world is not guaranteed to remain habitable. Venus was once more similar to us. Mars may have been as well. The universe carries no obligation to provide comfortable planets for fragile beings who cannot manage their own affairs. We possess knowledge sufficient to protect this world. Greenhouse physics is well understood. Nuclear winter dynamics are well understood. The carbon cycle and ozone layer chemistry are well understood. The question is not whether catastrophe can be avoided, but whether we will choose to avoid it. The cosmos extends vast beyond comprehension, ancient beyond imagination, and mostly empty and cold. But here, on this small world, something extraordinary happened. Matter organized itself into patterns complex enough to wonder at their own existence. That is not nothing. That may be everything. Responsibility for preserving this, for ensuring descendants exist to read history, compose music, look up at stars, and feel awe, belongs to us alone. No one else will do it. This fragile Earth is the only vessel we have. What we do with it over the next few generations will determine whether the human story continues for billions of years or ends in what amounts to tomorrow morning on the cosmic calendar. That is what fragility means. That is why it matters. That is why every choice we make, from energy consumption to leadership selection to values transmitted to children, is not a small thing. It is everything.